So now we're going to move on to finding unknown coefficients and points on a graph. So let's just remember to write a function. We're moving into graphs and graphing functions soon, but to write a function we may say f colon x maps to 2x plus 3. That's one way of writing a function. We may write the same function as f of x equals 2x minus 3. We may even say that y equals 2x minus 3. Same function, three different ways of writing it. Okay, and we've met in coordinate geometry that the equation of a line is given by y equals mx plus c, where m was the slope of the line and c was where the line would intersect the y-axis. Now we can say for this chapter y equals ax plus b. These are known as the coefficients. Okay. And a graph of the couples or points generated by this or these functions here would give a line, a straight line. So the general approach to finding unknown coefficients is that we'll be given points or couples, same thing, and we'll substitute those given points into the suggested form. So if it's a line problem, we'll put it into y equals ax plus b, and we'll solve for the unknowns using simultaneous equations if necessary. And just be careful and be ready to note that in the problems we're given, they might say if f of 2 equals minus 2, do something, find something, or if 1 comma 5 is a couple of the function, or if g comma 1 is 2, find, well, 2 minus 2 is a point or a couple of the function, so is 1, 5, and so is 1, 2. These are three different ways of writing or giving you the points that you must work with to solve the problems. It should become clear in a second now. But we may be asked to find unknown coefficients, but we have to use simultaneous equations. Okay, so this example, the given diagram shows part of the graph of the function y equals ax plus b, find a and b. So you're given 2 points, minus 1, 2, and 3, minus 2. How do you solve it? Well, you take the first point, you note its x and y coordinate, and you sub it into the form y equals ax plus b, because you're given a line and you're given the form. Okay? And you generate an equation 2 equals minus a plus b by plugging there in for x here and 2 in for y. You do the same at the second point. You note your x and your y, you sub it into the form, and you have a second equation. You solve these two equations by putting them on top of each other, and you change the sign and add. Okay, so you have 2 equals minus a plus b, it's the first equation, and minus 2 equals 3 plus b is 4. So change the sign, change that, 2 plus 2 is 4, change the sign, minus a minus 2 is minus 4a, change the sign, they cancel. Okay, a equals minus 1, sub that back into either of these two equations, doesn't matter, okay, and you get a value for b equal to 2 minus 1, b is equal to 1. So therefore y is equal to x, y is equal to x plus 1. Okay, so that's finding the unknown coefficients for y equals x plus b straight line form. Let's look at parabolas now, not straight lines but parabolas, and these are generated by quadratic functions. So this is question 14 on page 466. The function f of x equals x plus bx plus c is graphed on the right. So it's graphed here, and we have a point minus 3, 0, and 0, minus 3. Use the graph to find two equations in b and c. So we take our first point, find its xy value, plug it into the function of that form where we see x and y, because f of x equals the function, so y equals the same function. This is, it's good to rewrite it so we see our y clearly. Y is 0, so we put that in here, and we solve for that, and we get an equation minus 9 equals minus 3b plus c. We do the same for this point, and we get minus 3 equals c. So actually we found c already. We can sub that into this equation here, and we find b. And therefore, once we've found b and c, we can rewrite the equation x squared plus bx plus c as x squared plus 2x, because that's our b, minus 3, which is our c. And then we're asked further to solve the equation. So we have x squared plus 2x minus 3. We find the factors of those. They're all equal to 0. Okay, and basically x plus 3 equals 0. X is minus 3, and we know that because we can see it there. And x minus 1, 0, x is equal to 1, 0. So that helps us to find d. They've asked us to find d by solving the equation. And how we know that d, or it shows us that d is on the x-axis where the line, the x-axis, where a quadratic cuts the x-axis, where it cuts or intersects the x-axis, they're known as the roots, or the zeros, y values are zeros of the equation. Okay, so if you let any quadratic equation equal 0 and find the factors of that equation, let those factors equal to 0, you'll find the x-coordinate of the points where the curve cuts the x-axis.